So in this video we will discuss the question number 44 of GATE 2015. Ki of a novel competitive inhibitor designed against an enzyme is 2.5 micromolar. The enzyme was assayed in the absence or presence of the inhibitor, which concentration is 5 micromolar under identical condition. The Km in the presence of the inhibitor was found to be 13 micromolar. So they are asking what will be the Km in the absence of the inhibitor in the unit of micromolar. So before trying to solve this question, we will first check the competitive inhibition. What is the competitive inhibition? So in competitive inhibition, if you will see that schematic, then you can see that enzyme will bind to the inhibitor to form EI, and also enzyme has a binding affinity to the substrate to form the ES. Now here the substrate and inhibitor are sharing same binding site. In the case of substrate will come to bind the enzyme and make this ES complex and also inhibitor will compete with the substrate to get the access of the same binding site to make the EI complex. So there is a competition between the substrate and the inhibitor because their binding site is same, right? So after the formation of this ES complex, substrate will be converted to the product and enzyme will be released to form E. So now as the main feature of this competitive inhibition, that I and S inhibitor and substrate, they have the same binding site and they will compete with each other to get this binding site. So if we will plot this 1 by V versus 1 by S in the case of competitive inhibition, then we can see that 1 by V naught equal to alpha Km by Vmax into 1 by S plus 1 by Vmax. So in this equation, if we will compare with the y equal to mx plus c, then the slope or m of m will be alpha Km by Vmax or Vm, right? Where again alpha equals to 1 plus I by Ki. I equal to inhibitor concentration and Ki equals to equilibrium constant of this reaction EI of this reaction E plus I to EI, and the same for the backward reaction. So for this reaction the equilibrium constant is Ki. So alpha equal to 1 plus I by Ki, and slope of this equation is alpha Km by Vmax. And if you will write the equation without the inhibitor, then if I equal to, so in this equation if I equals to 0, then in the absence of the inhibitor, when I equals to 0, then alpha equal to 1, right? So in the case of alpha equal to 1, when I equals to 0, then the slope will be Km by Vmax because alpha equal to 1. So in the absence of the inhibitor, I equal to 0, the equation will be 1 by V equals to Km by Vmax into 1 by S plus 1 by Vmax, right? So if you will follow, you can see the intercept. Here also intercept is 1 by Vmax in the presence of the inhibitor, and in the absence of the inhibitor also intercept is 1 by Vmax. So in the competitive inhibition, intercept length will not be changed, right? Intercept length will be same, but the slope will be changed. So as you can see that for the inhibitor presence, the slope is alpha Km by Vmax, but in the absence of the inhibitor, the slope is Km by Vmax. So that means as when I and when I is greater than 0, that means there is presence of inhibitor, then alpha will also be greater than 1, right? Alpha will be greater than 1. From this equation, if I greater than 0, then alpha will be greater than 1. So this value alpha into Km by Vmax will be greater than Km by Vmax. That means what? The slope in the presence of the inhibitor is more than the slope in the absence of the inhibitor, right? So so in the competitive inhibition Vmax remained unchanged. If you will see both of the equation, presence of the inhibitor and the absence of the inhibitor, so Vmax is same, right? So that's why intercept length is same, but Km will be increased, and right, because here you can see the slope of the presence of the inhibitor is alpha Km by Vmax, and in the absence of the inhibitor is Km by Vmax, and this slope in the presence of the inhibitor is more than the slope in the absence of the inhibitor, and the Km dash, right, Km dash will be alpha. Km dash is Km in the presence of the inhibitor, that is alpha Km, and Vmax dash will be Vmax, right, because Vmax will be unchanged. Km dash will be alpha Km. So as Km dash is alpha Km and Vmax is unchanged, so that's why the slope is alpha Km by Vmax. So in competitive inhibition, Vmax remain unchanged, but the Km is changed to alpha into Km, right, in the case of competitive inhibition. So according to the question, Ki is given 2.5 micromolar, inhibitor concentration is given 5 micromolar, Km with inhibitor or Km dash is given 30 micromolar. So they are asking to find the Km without inhibitor, right? So in this equation we have showed that Km dash equal to alpha into Km. So Km dash equals to alpha into Km, where Km dash is the Km with inhibitor and Km is the Km without inhibitor. So Km dash so Km equals to Km dash by alpha. Now what is the value of alpha? Alpha equal to 1 plus I by Ki. So inhibitor concentration is 5, Ki is 2.5 micromolar, and inhibitor concentration is 5 micromolar, so it will be 1 plus 5 by 2.5, so it is 3. Alpha equals to 3. So Km equal to Km dash by alpha. Km dash is given 30 micromolar. 30 micromolar divided by alpha equal to 3. So answer is 10 micromolar, right? So the Km in the absence of the inhibitor is 10 micromolar.